In other words, if you started, don't think that you could go away for 10 minutes or 20 minutes and have lunch and then come back. Your time will run out. Once you start, this time runs out. And after an hour and a quarter after you've started it, your test will automatically submit. Those of you who've done the practice midterm should have realized that that's what happens. Again, if somebody ends up with a problem, I'm talking about the actual midterm. The actual midterm is going to be available this afternoon, starting at 2 o'clock, right after this class. But what I said about it is also true about the practice midterm. I set up the practice midterm so that it actually was the same setup that you'll see in your regular midterm, so you will be familiar with it. Again, once you sit down, I'm not specifying that you have to take it at 2 o'clock this afternoon. I'm giving you a space of time. If that time slot doesn't work for you, if there's no time that you can do it, then just email me, and if you have a valid reason, I will work with you. We will have regular class on Thursday. The midterm, the tests are done outside of class. That'll be true even with the final. This way, I do give you a period of time where you can pick what's good for you to use, rather than me saying, okay, when we're going to have the midterm on Thursday during class. That is too limiting for everybody. What I'm going to do now is I'm going to review the last things that we were talking about when we were in class on Thursday. I'm going to do a couple of problems of the type that we were doing last time. And then I will stop once I finish that topic, which is rational equations. I'm then going to stop for a few minutes, give you an opportunity to ask me any questions you would want me to answer in terms of the midterm. If there are no questions or nothing, no topics that you want me to go over, then I'll continue with chapter 5. Now, what we're doing today is not on the midterm. This is chapter 5. The midterm covers through chapter 4. But of course, you're going to have to know this material for the finals, so therefore it's important for you to know. So I'm going to put 2 problems on the board that as a review of the things that we learned on Thursday. Here are the 2 problems. Problem number 1 is, these are to solve for x minus 4 over x plus 9 equals 7 over 6. This is our first problem. These are equations. They are what we call rational equations. Rational equations are simply equations with fractions. And the second problem I want you to do is a similar problem. X plus 2 over 8 equals negative 1 over x minus 7. I'm going to give you a few minutes to try these out. While you're doing this, I will take attendance. Again, and you are to do the midterm on your own time. There is regular class on Thursday. It's not being given during class time. You have until Thursday evening to complete it. But again, you can't do it in 2 sessions. You have to do it all in 1 session, in 1 sitting. Okay, so let's look at this first question. This is the type of rational equation. It's called a rational equation because it has fractions in it. It is also called a proportion. It's a single fraction equaling to a single fraction. And one way of solving it, the way that we discussed on Thursday, is by what's called cross multiplying. You multiply the numerator of the first fraction times the denominator of the second. In other words, you do x minus 4 times 6 and set that equal to the numerator of your second equation, and second fraction, times the denominator of the first. It's called cross multiplying because when you're multiplying, you're sort of making an x. You're going this times this and this times this. The advantage of doing that is once you've done the cross multiplication, you do not have any fractions left. You just have a regular equation. Now, of course, you want to use your distributive property to remove the parentheses. So this is x times 6 is 6x. Negative 4 times 6 is minus 24. And that's equal to 7x. And 7 times 9 is 63. Don't forget, you are allowed to use a calculator. A regular scientific 2-line calculator is what you're allowed to use. Okay, we're going to then bring all the x's. This is a linear equation. There are no x squareds in it. So we're just going to bring the x's to one side. I subtract 7x from both sides. 6x minus 7x is negative x minus 24 equals 63. I then add 24 to both sides. So I get negative x equals 87. And I divide by negative 1 because I want what x is. I don't want what negative x is. So this gives me x equals negative 87. And that would be the way you would do this equation, this proportion where you cross multiply. The second equation is also a proportion. It's a single fraction equaling to a single fraction. So again, I am going to use cross multiplication. I'm going to do the x plus 2 times the x minus 7, numerator times denominator, and set it equal to 8 times negative 1. Again, denominator times numerator. Again, here's our x, our cross multiplication. Now, over here, we have to be a little bit more careful because here we have 2 binomials that we're multiplying. And in order to do that, we have to use FOIL. So we do x times x is x squared. Outer is negative 7x. Inner is plus 2x. And last is 2 times negative 7 is negative 14. And that equals 8 times negative 1, which is negative 8. And as I look at this equation, this is a harder equation because this is what we call a quadratic equation. This equation happens to be have an x squared in it. Well, we know how to solve quadratic equations. We have to get it equal to 0. So I combine the like terms. So I have x squared. The negative 7x plus the 2x is negative 5x. Minus 14 equals negative 8. And I have to add 8 to both sides, so I end up with it equal to 0. So this gives me x squared minus 5x. And negative 14 plus 8 is minus 6 equals 0. And we know with a quadratic equation, we then try and factor. So the x squared we break up into x and x. Remember, we look at our last term, which is negative. You do have to know, you wouldn't be asked this question, but you could be asked something like this on your midterm. You do have to know how to solve the regular quadratic equation. When the final term is negative, it means one sign is positive and one is negative. And you need two numbers that are going to multiply to 6, but when you subtract them, you're going to get 5. Now here you got to be careful. You wanted to subtract and get 5, not add and get 5. So the answer has to be 6 and 1. And since the middle term is negative, the 6 goes with a negative and the 1 goes with a positive. And then remember what you do with the quadratic equation is you separate each factor. So you get x plus 1 equal to 0 and x minus 6 equal to 0. So one answer you get is x equals negative 1. And the other answer you get is x equal to 6. So this one, of course, was a harder one, but the idea is the same. You cross multiply and then solve the equation that you get. Once you cross multiply, you no longer have fractions and you just have a regular equation. Sometimes we call a linear or first degree equation, no x squared, and sometimes a quadratic equation, that's if x squared comes out. Was anybody able to get either of these answers? Okay. No, I'm not going to ask you to mail me in the sheet with the work. You just have to do the, Naira, you just have to do the work and do the test. I'm not asking you to mail in the okay. Are we okay with this now? All right, so then let's go on to the next topic. What happens if we have rational equations, but they're not proportions? How can that happen? Well, let's take an example like this. Suppose I give you 5 over x plus 2 over 3x equals 7 over 6. This is also a rational equation. It is an equation that has fractions in it, but it's not a proportion. How do I know it's not a proportion? Because on this side of the equation, I happen to have more than one fraction. If I have either two fractions or a fraction, a whole number, if I have more than one fraction on a side, then we cannot use that cross multiplying method. Then we use the method that's called the least common denominator method. The cross-multiplying method doesn't always work with these rational equations, but the common denominator method always does work. Let me show you how the common denominator method works. The first thing you have to do is find a common denominator of the whole equation, not just one side, but of the whole equation. So remember, when my denominators are monomials, single term, I first look at the numbers, the coefficients. So really this coefficient is a 1, this is a 3, and this is a 6. The number that works for all of those is 6, because 3 can divide into 6, 6 can divide into 6, and 1 can divide into 6. Then we look at the variables, the letters, and we pick the highest exponent of the variable that we see throughout. And the highest variable we're seeing is just a 1, the highest exponent. So my least common denominator is 6x. So here's what I do with that LCD. I take that least common denominator, the 6x, and I put it over 1, and I multiply the whole equation, both sides of the equation, by the LCD. Now, we've done this before, even with simpler ones, but this is what's called the common denominator method. Now, let's see how this works. The first thing I have to do is distribute the 6x over 1. So it's going to be 6x over 1 times 5 over x plus 6x over 1 times 2 over 3x equals 6x over 1 times 7 over 6. And we're going to multiply all of these. Remembering that when we're multiplying fractions, we first try to cancel out numerators with denominators. Remember, we're multiplying. We're not cross-multiplying. We're multiplying. But the x over here cancels out with the x over here. Remember, when everything totally cancels out, it becomes a 1. So the first term I get is 6 times 5, which is 30, over 1 times 1, which is 1. Which I could have just written as plain 30. Then I go over here. The 6 can cancel with the 3. This becomes a 2. And the x cancels with the x, so this becomes a 1 over here. In other words, 3x cancels into 6x and gives me 2. So I get 2 times 2, which is 4, over 1 times 1, which is 1. And finally, over here, the 6 cancels into this 6. That leaves me an x over here, and over here a 1. So this is x times 7, which is 7x over 1. Now, you know that I really don't need to write it over 1. This really means 30 plus 4 equals 7x. In other words, anything that turns out to be over 1 is really a whole number. We don't have to put in the denominator. And actually, by multiplying by the common denominator, we've made this whole thing happen. We've made all our denominators turn into 1, so we no longer have fractions. Again, now it becomes an easy equation to solve. 30 plus 4 is 34. That equals 7x. So my answer becomes 34 over 7. Don't be scared of fractional answers. This is a chapter on fractions. It's not surprising that we should get an answer that is a fraction. But this is what's called the common denominator or least common denominator method of solving a rational equation. Okay, I want to try another one that's harder. And before I say that we are finished with this topic. Okay, so here's the next question I'd like you to do. Okay, I'm going to erase this now. Yes, I will, Shania. I will, after I finish this, I'm going to stop and answer any questions that you have on the midterm. Want to complete this topic of rational equations. I'm really basically going to do one more question, and then I'm going to stop and answer any questions that people have about the midterm. If there's time after that, I'll continue with the last topic in this chapter, but I'm first going to answer questions. Okay, so let's look at this. Suppose I gave you this question. I'm actually doing one from the sheet here. It's 2 over, it's question number 12 on the practice, the chapter 5 practice sheet. It's 2 over x minus 3 plus 1 over x equals 1 over 2x squared minus 6x. We're going to see that this is going to take quite a bit of time to accomplish because this is a hard problem. And then at the end, I'm going to give you some hints as to how to handle this as when you're dealing this as a multiple choice. There are automatically some types of examples that take a lot of time. This is a time-consuming example. Remember what I said. This is the type of example that if you don't think you're going to have enough time to do the whole problem, the whole test, you leave this to the end because it takes a lot of time. Again, this is going to be on the final. It's not on the midterm. It's a rational equation because I have fractions and I have an equal sign and I want to solve this equation. And it's not a proportion because I have more than one fraction on a side. So I have to use the common denominator method. And the first thing I have to do is find the LCD. Now, if you recall, in order to find the LCD, I have to factor all my denominators. Well, there's nothing to factor with the x minus 3. There's nothing to factor with the x. But over here, the 2x squared minus 6x, you can factor it. Remember, you always look for a common factor first. There's a common factor of 2x. If you put the 2x on the outside, you're going to get 2x into 2x squared is x. 2 into negative 6x is minus 3. And if you recall the method we found using to find common denominators when we have polynomials, we start with our first denominator and circle that whole thing. We then go to the second denominator. Do I have a plain x circled yet? No, I have an x minus 3. Remember, a binomial is a unit. You can't separate the pieces. So I have to circle that. Then I go to I have to do this throughout, so I have to go on the other side. So what do I have on this side? I have a 2, an x. Remember, the 2 and the x are each factors, and the third factor is x minus 3. Well, I don't have a 2 circled yet, so I better circle it. But I do have an x circled, and I do have an x minus 3 circled. So if I take all of these three things, the 2, the x, and the x minus 3. Now, you don't have to, you could have just written this as 2x, but I wanted you to see that the 2 and the x are two different factors. You put that over 1, and you multiply this whole thing by the equation 2 over x minus 3 plus 1 over x equals 1 over 2x times x minus 3. And just like we did in the previous example, we're going to distribute this. We're going to put this common denominator that's over 1 next to each term. So it's going to be 2x times x minus 3 over 1 times 2 over x minus 3 plus 2x times x minus 3 over 1 times 1 over x equals 2x times x minus 3 over 1 times 1 over 2x times x minus 3. The writing takes a lot of time. You have to be prepared to spend time on these type of problems. Now remember what we do. We're going, when we're multiplying, each of these is a fraction that we're multiplying fractions. And when we're multiplying fractions, we try to cancel out any like factor from the numerator and the denominator. Now over here in the first one, over here, I see an x minus 3 on the top and an x minus 3 on the bottom. And what we're left with then is 2x times 2. I'm just going to write what we're being left with. 2x times 2 over 1. Now remember, when it's over 1, we don't have to put in that 1. It's a whole number. Then, see what we have next. Over here, we have a 2x and an x on the bottom. This is a 2 times x, so this x can cancel out with this x. That'll leave the 1 here. And what I'm left with over here is a 2 and x minus 3 times 1, so I don't have to put it over the 1 in. Over 1, I don't have to put it over 1. I can leave it just as a whole number. And finally, over here, the 2x's cancel out. The x minus 3 cancels out. This becomes a 1, this becomes a 1, and then I'm just left with 1 times 1, which is 1. And now we have to finish solving this. 2x times 2 is 4x plus 2x minus 2 times 3 is 6 equals 1. And this gives me 6x minus 6 equal to 1. I bring the 6 to the other side. That gives me 6x equals 7. And my answer becomes 7 over 6. Again, remember what I told you. Do not be scared that your answers are going to come out to be fractions. It is a chapter on fractions. It's very likely your answers could be fractions. So this is an example in which you have polynomials and you still had to find the common denominator. Okay, I'm going to try and find one more example for you to try. I'm going to give you one to try. Suppose I gave you this problem. X plus 6 over x plus 3 equals 3 over x plus 3 plus 2. Now I'm going to start you off on this example, and then I'm going to give you time to try and figure it out. It's not a proportion. How do I know it's not a proportion? Because even though I have a single fraction over here I happen to have a fraction plus a whole number. Now, in order to avoid confusion, when I first start, I'm going to put this whole number 2 over 1 so that I can see what your denominators are. Okay, I'm going to give you a few minutes to try this problem on your own, and then we're going to work on it together. And after that, I'll do some problems from the midterm. Okay, I think we should try working on this together now. Again, we're going to have to use our common denominator method because we have more than one fraction on a side, which means we have to find our least common denominator. And everything's in simplest form. There's nothing to factor. And remember, I'm going to circle my different denominators. Well, here there's an x plus 3. I already have an x plus 3 circled. And a 1, we never really have to put in a 1 as part of it. X plus 3 times 1 is x plus 3. In other words, my common denominator that I'm going to be multiplying by is x plus 3 over 1. I'm going to multiply the whole equation by x plus 3 over 1. So here's my multiplying by, you know what, I'm going to save myself a little writing. I'm multiplying this whole thing by x plus 3 over 1. So here's what we're going to have. We're going to have the x plus 3 over 1. Remember, we're distributing it, times the x plus 6 over the x plus 3 equal to the x plus 3 over 1 times the 3 over x plus 3 plus the x plus 3 over 1 times 2 over 1. And over here, when the x plus 3 over here will cancel with the x plus 3 over here. These will be 1. And I'll just have 1 times x plus 6, which is just x plus 6. Remember, it should be over 1, but we don't have to put it over 1. If the 1 is in the numerator, yes, we have to. But when the 1 is in denominator, we could just write the number without it. So we get x plus 6 on this side. And over here, the x plus 3's again cancel out. I just have 1 times 3, which is over 1, which is 3 over 1. It's just 3. And over here, nothing cancels out, so I have to multiply the x plus 3 times 2, which gives me 2x plus 6. I could have put x was 3 times 2, but these are easy to do. Notice what a simple equation we've been left with after we get rid of the denominators. We left with a regular linear equation. We want to bring all the x's. Let's first combine the like terms. So we have x plus 6 equals 2x plus 9. We'll bring the x's to one side. So this will give me negative x plus 6 equal to 9. I'll bring the 6 to the other side. That'll give me negative x equals 3. And I'll divide by negative 1, so that x equals negative 3. So the solution to this equation is x equals negative 3. Once we remove the common denominator, we were able to solve a very simple equation to get this answer. Now I want to show you something interesting. I want to check the answer here. I want to see what happens when I check the answer. Let's do the check over here. In order to check the answer, I have to go back to my original equation and replace the x with negative 3. So in the numerator, I'm getting negative 3 plus 6 over negative 3 plus 3 equals to 3 over negative 3 plus 3 plus 2 over 1. Now, simplifying this, negative 3 plus 6 is 3. Negative 3 plus 3 is 0. That equals 3 over 0 plus 2 over 1. And what I notice is when I go to do the check, I end up with, sometimes it's 1, sometimes it's more than 1, of the denominators being 0. Well, we know that you cannot have a 0 in the denominator. A 0 in the denominator is not a real number. It's what we call undefined. Remember, if we got a 0 in the denominator for the slope, we said the slope was undefined. 0 as a denominator is not good. In other words, anytime I get something that doesn't make sense, I can't accept it as an answer. In other words, this answer is a faulty answer. I can't use that answer. Even though I did all the correct work, I came up with an answer that didn't make sense. Which means that if you ask me, what's the solution of this equation? Here's your solution. There is no solution. The only solution that we came up with is negative 3. We did all the correct work that we did negative 3. But when we tried to check it, it didn't work. It made one of my denominators, or more than one of my denominators, equal to 0. It's something called an extraneous root. Something that's extraneous is something that is extra that you don't want. You can't use it. You can't say, oh, x equals negative 3, but it doesn't work. There is no solution to this problem. I could have started out this problem and said, I could have made myself a list of possible answers that wouldn't make sense by just taking the denominator, the x plus 3, and seeing what would make it equal to 0. The denominators are x plus 3. If I set that equal to 0, that gives me x equal to negative 3. I would have known ahead of time, if I looked at this problem, that negative 3 could not be an answer because it would make a denominator equal to 0. How could that be a help? Well, when you Again, this topic is not on the midterm, but it will be on the final. Let's say you were given this question and it was a multiple choice question. And one of the answers that would be given is x equals -3. You could know right away that that answer does not make sense. Any answer that gives you -3 can't work because it makes the denominator equal to 0, which tells me that when I'm dealing with these rational equations, once I get my answer, I have to check back, is that answer going to make my denominator equal to 0? If it does, I have to reject that answer. I cannot take an answer. So sometimes I can do a whole bunch of work that is completely correct. Whatever I did here was completely correct, but still gave me an answer that was not a valid answer, and we had to reject it so that there was no solution to this problem. Okay, so what have we learned from this? Aside from solving these rational equations, we better check our answers. If you don't have time to check the whole thing, at least check that the answer you're getting is not making a denominator equal to 0, because then you're getting an extraneous root, an answer that is not valid. Sometimes you get two answers because it was a quadratic equation and one will work, but one won't. You just have to make sure that you're not getting an extraneous root. Okay. With this, I'm going to stop. And I'm going to talk about the midterm. Don't forget to keep looking on your Delta math so that you know that you keep up with the homeworks that are in Delta math. Anything that's any homework that's due on Delta math, I'm going to check the due dates, but I'm going to extend it into next week so that in case you want to concentrate on the midterm. Again, I'll say what I've been saying about the midterm all along. The midterm is like the practice midterm. It is 75 minutes. That means it's an hour and 15 minutes. Once you start it, once you open that first question, you have to finish the test in one sitting. There's no starting and going back. It is even though you're in your own home when you're doing this, it is something that you have to sit and do on your own. You are allowed to use a calculator, but you must finish the whole test in the given amount of time. All right, now somebody said they had some question. I don't remember who told me, who said they had questions they wanted to ask me from the midterm. Shania, did you want to ask me anything?
Yes.
Okay.
Can we, yeah. So are you gonna write it down or?
Yeah, I guess I am.
Okay.
Wait, let me erase the board so we have a fresh start. And thank you for asking questions, because that's the only way we all learn. Okay. You want to give me the question?
All right, so the first problem is, I forgot what you call those lines, but draw a line. A line, yeah. Yeah. This line, yes. Huh?
A line on a graph?
No. The absolute value line.
Oh, okay.
Yeah.
Okay.
6 minus 5/3x. Draw a line again. Plus 7. equal 14.
Okay. This is an absolute value equation, as you mentioned. And when we go to solve an absolute value equation, we know what we have to do is first isolate the absolute value. In other words, get the absolute value all by itself by subtracting 7 from both sides. Okay? We want to have only an absolute value. If there's anything outside that absolute value, get it to the other side. Once you do that, you stop for a second and make sure what you're looking at is a positive number. Whenever you have the absolute value, it has to be equal to a positive number. So once you have your absolute value all by itself, once it's isolated, look at what's on the other side. If it has a negative sign, you can stop right there. There's no solution. But this is a positive number, which means I have to write two separate equations. One equation is 6 minus 5/3 x equals 7. In other words, just the regular equation without those absolute value signs. And the second equation is 6 minus 5/3 x equals -7. So you're going to end up with two different equations to solve. Okay, here we are. Solving the first one, I'm going to first bring this 6 to the other side. I'm going to subtract 6 from both sides, which will give me -5/3 x equals 1. And that really, let's put this over 1s because now we have this fraction, right? And let's multiply, my common denominator here is 3. So let's multiply everything by 3 over 1, just like we were doing just before. So it'll be 3 over 1 times -5/3 x equals 3 over 1 times 1 over 1. And here the 3 cancels out, so that just gives me -5x. And here the 3 times 1 just gives me 3. And then I'll divide by -5. So one answer is -5 3/5. So my first answer is -3/5. You could have also just cross multiplied on this as well. I'll do the next one on cross multiplying. Again, I'm going to subtract the 6 from both sides. And that'll give me -5/3 x equals -13, which again, I'll put over 1. Just to do this one, let's cross multiply on this one. So it'll be -5x times 1, which is -5x. And 3 times -13 is -39. And divide both sides by -5. So the other answer is negative over negative is positive. It's 39 over 5. So here are your two answers, -3 over 5 and positive 39 over 5. Again, you could do it by the common denominator way, or you could do it by the cross multiplying way. We learned the common denominator. Is that clear to you? Are you
Yes,
okay?
it is.
Shania?
Yes, it's clear.
Okay, did you have other questions?
Yeah, actually, yeah.
Okay, so don't forget with an absolute value, you've got to get it by itself and then you have to write two separate equations
Yeah, I got far as that, but then I was so confused after that.
because of the fractions.
Yeah.
Okay, is it a little bit clearer now?
Yeah, it is. Thank you.
I wish they wouldn't have included fractions on these examples because there's so much else that you have to know, and I would have preferred concentrating on the absolute value, but I have to deal with the equations that they give me. Okay, I think it would have been better not to have any fractions so you could just check, concentrate. Okay, what's your next question?
I'm gonna let you erase it first.
What?
You can erase it first.
Okay. Fresh.
Okay, so it's negative 5.9b plus 2.8 equals 24.2.
24.2?
Mm-hmm. Minus 3.2b. No, 3.2b.
I put an extra one in there. Okay. Now, this is one that I really want to use my calculator. Once I have, with, I use it with fractions as well, but certainly when it comes to um, larger numbers or decimals, I right away go to my calculator. Okay, what do we have to do? We want to bring the b's to one side, the numbers to the other side. So the first thing I'm going to do is add 3.2b to both sides, correct? Okay. Now here's where my calculator is going to come in handy. You're allowed to use a calculator. I'm going to do negative 5.9 plus 3.2. That adds up to negative 2.7. So I get negative 2.7b plus 2.8 equals 24.2. Remember, this got canceled out. Now I have to bring this 2.8 to the other side. It's a regular equation. You just have to be careful because of the decimals. And again, I'm going to use my calculator. I'm going to do 24.2 minus 2.8, which will give me 21.4. So I end up with negative 2.7b equals 21.4. Now I have to divide both sides by negative 2.7. So I'm going to take the 21.4 and divide by negative 2.7. Now, what did the answer they give you? This gave me negative 7.9259, a lot of decimals. Do you remember what the answer was? Did they say round off?
See, these I got that exact same thing, but none of those answers were that. The first answer was 10. The second answer was negative 7.1. The third answer was 7.4. And the fourth answer was negative 20.
Oh, this is the correct answer.
Exactly. I was like, did I do something wrong? I did it twice and still didn't get.
Are you sure that the signs are correct? You didn't copy something wrong?
Nope. I took a screenshot.
Okay. I'm gonna go back and look, but they might, I didn't do the problems. I'm gonna go back to that problem. I'll email you when if I see what happened. But I can tell you this. I checked the midterm. I didn't check the practice midterm, which is what they sent me, but I did check the midterm. I did the midterm myself and all the answers were correct. I
Okay.
can't tell you that there's never been did anybody else do this problem or have this problem? Sometimes you see I might not come up with, they mix up the problems. You don't have the same problems all the time. Were there any others that you wanted me to do?
No.
Okay, do you feel pretty confident about the rest of the stuff?
Yeah, I do, I guess. Yeah.
Okay, good. Thank, okay, so I would like, since we still have like about, well, actually 25 minutes, but I'll keep you another 15 minutes. I just want to do one more topic since unless somebody else has some question that they'd like to ask me from the midterm. If not, then I'd like to talk about the one last topic in this chapter. When we did chapter 4 was a chapter on polynomials. And what we learned in chapter 4 was how to add, subtract, multiply, and factor polynomials. And we never talked about the operation of division. And actually, when we talk about fractions, fractions really have to do with division as well. So in chapter 5, the last topic that we deal with is the topic of division, and we're going to be dividing polynomials. Now, there are two aspects to this. We can divide a polynomial by a polynomial, or we can divide a polynomial by a monomial. Today, we're going to talk about how do we divide a polynomial, something with several terms, by a monomial, a single term. For example, this happens to be question 13 on the chapter 5 sheet, practice sheet. It's 15 a to the third b plus 30 a squared b squared plus 20 a b to the third over 15 a squared b squared. And the instructions tell me to divide. Sometimes it will say divide, or sometimes it will say find the quotient. The word quotient is used when we're dividing. It's the answer you get when you are dividing two items. So when they ask you to find the quotient, they're asking you to, or they ask you to divide. They're not asking you to reduce the fraction. This looks like a fraction, but it really is a division problem. And the way we handle it is we separate it. We take each of the terms of the polynomial, in this case there are 3 terms, it's a trinomial, and put them individually over the monomial. So I get this as, I rewrite this as 15a third b over the 15a squared b squared plus 30 a squared b squared over 15 a squared b squared plus 20 a b third over the 15 a squared b squared. We take each of the terms and separately put them over the denominator. And then we take each of those individual fractions and simplify them. If you recall, when we're simplifying fractions that are just made up of monomials, we first deal with the coefficients and then we deal with each of the letters separately. So I first look at the 15. I can cancel out the 15 from the top and from the bottom. Then I look at the a's. There's an a to the third and a squared. Remember, these are single terms, so we can take them apart. It's when we have binomials or trinomials that we have to leave them as units. So with the a squared and the a to the third, remember we always cancel out the one with the lower exponent, so that would be the a squared, and subtract that exponent from the higher exponent, so 3 minus 2 is 1. So therefore, I am left with just a plain a to the 1, or a in the numerator. Remember, you're left with the letter in the wherever the higher exponent was. With the b's, the lower exponent is the plain b, so that gets canceled out. And remember, that's understood to have an exponent of 1, so 2 minus 1, that cancels out, and this gives me b to the 1, which is b. In other words, what we have for the first fraction is a on top, b on the bottom. Remember, the letter always remains where the higher exponent was. I then go on to my second fraction. Between the 15 and the 30, I can cancel out 15, and the 30 will leave me a 2. The a squared and the a squared on the top both cancel out. When they both have the same exponent, they totally cancel out. Same thing with the b squared and the b squared. So that I'm left with nothing on the bottom. Remember, we don't leave it as a nothing, we put a 1. So the next answer, this next fraction, becomes 2 over 1, which we can write as just plain 2, because when you have a 1 in the denominator, you don't have to write it. And finally, you go to your last term, your last fraction. Between 20 and 15, you can cancel out a 5. 5 into 15 is 3, 5 into 20 is 4. On the a's, I have an a to the 1 on top, that cancels out. A squared, 2 minus 1 is 1, so it just becomes a to the 1 on the bottom, or just plain a. With the b's, the lower exponent is the b squared, that gets canceled out. 3 minus 2 is 1, so I have the b left on the top. So my last term, my last fraction becomes 4b on top over 3a. And this is your answer when you divide in this case, a trinomial by a monomial. You just take each term from the top and separately put it over that monomial, and then reduce each of those fractions. I'm going to give you one to try now on your own. Suppose I gave you 12x to the 5th minus 18x to the 4th minus 6x to the 3rd over 6x to the 3rd. I'm going to give you a couple minutes to try that on your own. Okay, I think we can work on this together now. I don't think this is one of those questions where this takes a lot less time than some of the ones that we were doing before. Again, we have a trinomial, three terms, over that's being divided by a monomial, 6x to the third. And again, it will either say divide or find the quotient. We separate it. We do 12x to the fifth over 6x third minus 18x to the fourth over 6x to the third minus 6x to the third over 6x to the third. Okay, in the first one, we have a 12 and a 6. We can cancel out the 6. 12 and 6 divided into 12 gives me 2 on the top. The x third and the x fifth, the lower exponent is the one with the x third. 5 minus 3 is 2, so I get x squared on the top. So and 1 on the bottom. So this becomes 2x squared over 1, which I can write as just plain 2x squared. Okay, going to the next one. 6 and 18. I can cancel out the 6 into the 18. That'll give me 3 on top. X fourth and x third. Again, the lower one is on the denominator. Remember, I'm always canceling out the one with the lower exponent and subtracting that exponent from the higher. 4 minus 3 is 1. So I'm getting 3x and the 3x over 1, which is just minus 3x. I don't have to put that 1 again. If the 1 comes out in the numerator, I have to put it in. But in the denominator, I could just leave it as a whole number. 3x is the same as 3x over 1. Don't forget that you're left with the letter, with the variable, where the higher exponent was. Finally, here both the 6's cancel out and the x cubes cancel out. So don't leave it blank. It's not blank. It's a 1. If everything cancels out, you're left with 1. So your final answer, I hope most of you got this, is 2x squared minus 3x minus 1. Okay, we're going to end class now. Again, don't forget, by 2 o'clock today, you will be able to access the midterm on Blackboard. It's being given on Blackboard. It's the same 75 minutes, unless you're entitled to extra time. If you are, if I got a notice from the office that you're entitled to extra time, I automatically gave you that extra time. Do not sit down and think that if there's going to be interruptions, you need to set a solid period of time, because once the time passes, the test will automatically be submitted to me. If there are no questions, don't forget, you have until Thursday, 10 o'clock, but that means you have to be finished by then, not that you should start by then. If none of these times work for you, if you can't do it in that time, just email me and tell me I'm not available at that time. Can you give me a different time? And I'll work something out with you. Just let me know. Does anybody have any questions? If not, then I'm going to say have a good afternoon. And I will see you. We will have regular class on Thursday as usual. Do not think that because you have the midterm this week that we don't have class. We have regular class.